Hi again. I hope you're all enjoying the event so far. For this next session, I'm happy to welcome John Sweeney, Vice President and Head of Global Sales at XCOM RAN Globalstar, to discuss bridging IoT and OT for smarter operations. John, before diving in, can you provide us with a bit of an introduction to XCOM RAN Globalstar?
Yeah, I'd be happy to do that. Thank you, Catherine, and thank you for the opportunity to join, and thank you for those that have joined the seminar here. So, yeah, Global Star, I know it doesn't exactly just roll off the tongue as a traditional private cellular provider. So, Global Star is a publicly traded company, has been providing satellite services in 120 countries around the globe for over 30 years. But a couple of things happened that really expanded its product offerings. So the first thing was they secured some of the satellite spectrum for use in terrestrial applications. And 3GPP specifically designated it as Band 53. In parallel, they acquired a company called XCOM Labs, which was founded by Qualcomm leadership, specifically Paul Jacobs, CEO, and the CTO, Matt Grube. And they brought to the table just absolutely revolutionary and innovative wireless technology for a next generation private 5G solution. So what you ended up with was a very powerful and unique combination. So the XCOM RAN solution, which we'll spend the bulk of the time talking about today, but also it is a spectrum agnostic solution, but it comes with it access to dedicated and licensed spectrum. We'll touch on the importance of that as well, and then backed up with satellite assets. So let's go a little bit into what is XCOM RAN. So XCOM RAN is what we believe is a superior private 5G solution. It is fully 3GPP compliant. And why is that important? Well, it ensures a robust and secure ecosystem and compatibility and interoperability with devices, applications, and other network elements. We chose to use the Open RAN architecture, and we did so because we wanted to make this software defined. So we really wanted to do the software hardware disaggregation and put the majority of the intelligence in the software. So why did we do that? And then, the all important question when people start talking about technology is so what? So the as I said before, the product is completely software defined. We took the intelligence, even some of the intelligence out of the radios themselves and put it in the baseband unit, or in this case, the DU specifically. And we use a coordinated multi-point radio system, which centralizes the scheduling across the different radios, which just dramatically improves both the uplink and the downlink performance, even in the harshest RF environments or really densely packed areas. And it creates a spatial massive MIMO with advanced beamforming, which delivers really higher spectral efficiency, extended coverage, higher availability, and improved mobility handoff, which is rapidly becoming much more important in industrial and autonomous environments. So again, this kind of leads into the, so what? What does all this do? Well, this is really about empowering industrial automation and robotics, aerial and autonomous systems. So drones, whether they're, geofencing or in ports, they're inspecting hazardous cargo, you name it. And that really then ties into really high density video and data and sensor uplink. It's amazing. We heard at the conference not too long ago that something like 90% of data that's collected in IoT sensors goes unused. And it's this data that really allows for intelligent edge analysis and closed loop automation. And that's really what this thing ends with is, what we're focused on is mission critical operations and really helping enable that. So what we're not talking about is, can somebody download the latest, episode of their favorite show or film in the airport lounge before a transatlantic or Pacific flight? This is really about, ensuring that there is no downtime where if you shut down a production line or a distribution center comes to a grinding halt, or boats start lining up at a port because communications are down, you're costing the enterprise tens of thousands, if not hundreds of thousands of dollars in lost productivity per hour. And that's really what we're aimed at. So hopefully that gives a little bit of context into what XCOM RAN brings to the table.
Yeah, absolutely. And you really shared a lot there. But I want to pick out
Yeah,
something you said.
we packed
You
intense
mentioned
there, I
software
know.
defined. You mentioned
The,
software
the
defined.
plutonium message, so to speak.
And we've heard the term software defined networking for years. I certainly know I have. What does it actually mean when applied to the RAN? How does this change how industrial networks are built and
No,
evolved?
that's a great question. So in the RAN, what the software-defined networking does, it replaces your rigid, kind of static, hardware-centric cellular system with a software-defined system where the radio, the core, and the edge functions all are software. So it lets enterprises, industrial operators, whomever, both evolve and scale connectivity just like any other sort of IT application, pushing new capabilities, security updates, and performance tuning without actually having to touch the hardware itself. So it turns the RAN into something that is agile, programmable, and living and constantly evolving and improving rather than a static fixed asset that someday is going to have to be forklift upgraded.
Right. Okay. So we keep hearing about edge, physical AI, and OT and IT integration, and that's what we're here to talk about today. How does software defined, as you just illustrated, 5G actually bring these two worlds together, especially in environments like ports or factories where latency, security, data ownership, that kind of thing are so critical?
Well, we've lived in a world of stovepipes for years. So when you have a software defined private 5G, it creates a single fabric that connects all the machines, the devices, the sensors, the people, and the enterprise systems in with deterministic performance with a very, very low latency. The data, and that immense amount of data that's being pulled in, that telemetry, all stays on premise, which means operations maintains ownership, security, and data sovereignty, all of which is critical. And then IT gains a standards-based system that is perfect for automation, analytics, and AI. So think of it as kind of a convergence layer where OT trusts it for reliability and safety, and IT trusts it for integration, security, and scalability. If that makes sense.
Yeah, yeah.
Right.
And you've tested XCOM RAN in a lot of these environments, right?
Yeah.
Warehouses, ports, airports. As you've done that, what surprised you the most? Like some of the technical hurdles, the cultural ones, or how IT and OT teams collaborate on site?
You just said it. So first of all, because the technology works, the surprise isn't so much for us, but the surprise is for the users, and it really is cultural. So you go from these stovepiped organizations that are often operating in separate silos. So when OT, IT, and the automation vendors all get on the same page, they're all on the same private 5G network. They start solving problems together that were, well, let's honest, were impossible to do so with Wi-Fi or siloed system. And the moment that they see deterministic wireless replacing, cables, forklifts with autonomy, or real-time computer vision and data analytics at the edge, you see that cultural shift to embrace and adopt and accelerate IoT and physical AI at a much more rapid pace. Much
Yeah.
more rapid pace.
Okay. Yeah, and let me ask like kind of your classic comparison question here. So XCOM ran Global Stars N53 spectrum gives you licensed interference-free lanes for private 5G. How does that approach differ from CBRS or Wi-Fi in delivering deterministic connectivity
No,
for
that's a great question. It's one we actually get a lot. So as I mentioned before, XCOM RAN is spectrum agnostic. We can do CBRS. We can do pretty much any TDD spectrum. We prefer TDD because it helps with both the uplink and the downlink flexibility. But what's important to keep in mind is that CBRS is shared licensed spectrum. Wi-Fi is completely unlicensed spectrum, which means latency and reliability are directly related to who else is transmitting in the same band. Who else are you swimming in the same lane with? So with Band 53, XCOM RAN gives the enterprise or the industrial operator licensed interfree spectrum, or basically their own private lane. So performance is completely predictable, service is assured, even in the noisiest RF environment and arduous environments, whether it be the metal lattices of warehouses or seaports, manufacturing facilities, et cetera. And it's that combination of the technology and the dedicated spectrum that make autonomy, robotics, especially mobile robotics, in real-time AI workloads completely viable and reliable over wireless.
Yeah. Okay. And because XCOM RAN runs on COTS hardware and cloud native control planes, what does this whole industrial grade 5G as software, what does that mean for cost and scalability and life cycle management?
Yeah, but I tell you what, it's about a dollar for every buzzword in that
Yep.
sentence there that we have to unpack.
It's impressive.
That's my retirement plan is all these buzz terms. No, so because the XCOM RAN baseband sits on a COT server, scaling the network is really like scaling a data center application. So all you have to do is add compute, deploy new coverage, or push out new features and applications just like you would, anything else via software. So what this does is it eliminates proprietary hardware lock-in, and it makes the lifecycle management into really more of a continuous development and continuous delivery engine. So updates, network and application optimization, security patches, all these things are pushed out automatically. And the outcome is, first, a lower cost of ownership. But more importantly, it's a network that's able to, and we like to say, you can innovate at the speed of software. We don't even know what we don't know yet. And having a network that allows you to upgrade without having to forklift things in and out to do so is, excuse the pun, hypercritical in this day of hyperscalers and AI and edge IoT.
Yeah, and to keep talking about, this age of AI, as AI and autonomy shape, or I should say reshape
Yeah.
industrial operations, what's next for software defined 5G and everything we've talked about today?
Well, there's a lot of things, that are coming next. And as I said before, some of it we don't even know yet. But some of the things that I think about is, multiple supercells. So as I mentioned before, we create a single supercell. You can have multiple supercells, so you can start having coverage well in excess of a million square feet or greater. You can, have AI orchestration, satellite backhaul. I mean, all of these things, are a software upgrade as opposed to a forklift rebuild. And as you mentioned, and I'll stress again, the future for autonomous networks is, the ability to self-tune for latency, for mobility, for energy and carbon footprint, and for interference. Especially out of band and environmental interference, which powers robots, vehicles, and AI systems at massive scale. We're no longer talking about 5 robots or 10 robots at a plant. We're now talking about hundreds, if not thousands, of robots. In fact, there's a major retailer that starts with an A. I mean, they're over 1 million bots now. So we're talking about massive, massive scale. So essentially, what we're talking about is transforming the RAN into a high-performance computing platform that empowers, intelligence at the edge, if that
Yeah,
makes sense.
absolutely. So we have a few minutes left here, and I just wanted to ask you if you had any final thoughts or key takeaways that you'd like to leave us with.
Yeah, no, thank you. So, I think we've touched on a lot of things, but I think the important thing is that if you look at AI and take all the Terminator, Skynet, AI is going to rule the world, stuff aside, what we're really looking at is an inflection point in the industry that I think is not only going to rival but surpass the use of the internet that happened at the turn of the century. Boy, I feel old when I say the turn of the century, and I'm not talking about 1899 going to 1900. But no, what we're really talking about here is a seismic shift, not just in how enterprises and factories and seaports operate, but literally how we all live, work, and play. I think the shifting from the large language models and AI modeling to AI inference and then the manifestation into physical AI is literally going to be a transformative change in the way we all live, work, and play. But all of it is hyper dependent. Again, no pun intended, but is hyper dependent upon the connectivity. It all falls apart if you don't have reliable, dependable, secure communications to tie it all together. And to do so in such a way that can keep up with the speed of innovation. And that's happening at the speed of software. So you need a network that is innovating at the same pace, if not at a faster pace. So you can ensure that your business operations can take advantage of whatever the latest comes down the pipe. And I think that really is the key message for people to take away is that, we're running into a brave new world. And with it, you need a brave new network to ensure strong connectivity. And I kind of circle back to, my initial comment around, Globalstar and XCOM RAN, isn't a traditionally known or a traditional private cellular provider. And that's fine because guess what? We're no longer living in a traditional world. So it's a perfect match. And I, for one, am just absolutely thrilled and excited to see what's coming next. And I feel happy and very, very confident that we can meet any challenge that comes down the pipe as it comes.
All right, excellent. I think we'll end there. Thank you, John, so much for your time, and thank you everyone for
Fantastic.
joining us.
Thank you, Catherine.
Yeah, thanks. Bye.